Hello, guys. So today we'll be looking at setting up and also the calibration of the UT flow detector. This is basic and fundamental to any UT technician that wants to perform a wet scan. We'll probably do a 2 or 3 parts video for us to properly cover this and then look at some simple tricks and things we can do to make our calibration and setup easier and more accurate. Then also the whole concept of equipment check, equipment calibration, equipment setup. They are basically not the same if you look at it in principle. So we are going to look at them when you are doing equipment check and then when you are doing equipment calibration. So let's dive in. Okay. Oftentimes there is this confusion about setup, calibration, and then the third part, which is equipment checks. So let's try and break them down. So the first one is setup. In the true sense of it, setup does not really require uh, you to perform any form of calibration. So what you are basically doing when you are setting up your UT equipment, you are entering your parameters. This could be your velocity, your probe type, your probe angle, your index points, and those essential values that you need for your UT machine to work properly. So setup may be dependent on the kind of machine you are using. Maybe you are doing you want to do lamination check, or you want to do your corrosion mapping, or you are doing wet scan. The setup definitely will vary depending on what you are doing. So when you are imputing those parameters into your machine, adding values, choosing options, you are basically doing setup. A very popular question that some people will ask is, if you do your setup and you try to maybe perform thickness or perform a wet scan, are you going to get indication? Yes, you are going to get indication. The only thing is that your indications will not be accurate in terms of their dimension. In the sense that if you are measuring thickness of a plate, if you do not calibrate, you will not get accurate thickness. But you will still be getting your back wall echoes. They will not be where they are supposed to be on your UT machine. So that is where calibration comes in. So calibration now involves you setting up your equipment with known thicknesses or known indication that are of specific depths that are known. When you do that, that is when you are not doing what we call calibration. Oftentimes you hear people say, I'm calibrating my machine, calibrating my machine. A lot of the activities that people do when they are doing calibration is actually set up. So calibration is just maybe a couple of steps. If you are saying you are setting up for thickness, you just need to know have a known dimension in a block and you compare. The whole essence of calibration is because one, there will be what we call variation in velocity. Then there is also the second issue of what we call the delay. When we say variation in velocity, if you read a couple of UT books, you discover that, for example, let's say for velocity of steel, for longitudinal wave, some books will tell you it's 5920, others will tell you 5900, others will tell you 5950. So it depends. Does that mean these velocities are wrong or one is correct and the other is wrong? Definitely not. Even steel as a material is an alloy of iron and carbon. So you always have this variation in the material constituent. So at the end of the day, the velocities will vary, which means irrespective of the velocity you choose, you are going to get a specific thickness as a value if you are, say, you are calibrating for thickness. So how do you now correct it so that the thickness you are getting becomes the accurate thickness. That is where calibration comes in. So with your delay now, so with your delay in this case now, you use this delay value now to adjust your velocity variation. Then when you look at delay mainly too, some probes come with delay. So I can have a probe and have an external attachment, a pass glass, to cancel out the near field or dead zone effect. This also introduces delay, which will also affect your thickness. So when you are performing your calibration, you are going to do that with the aid of what we call the machine inbuilt delay. So it depends on the manufacturer of the equipment. Some you might have what to call your equipment zero, or some machines will call it zero delay. What the zero does is if I have, let's say I have an indication, I have a block, let's consider this as a probe, and I have a block and I'm trying to calibrate. Definitely, I'm going to get my reflected backward from this, which will give me an echo here. When I adjust the values of my zero or zero delay, the echo begins to either shift backward or shift forward. As this happens, the value of your thickness that you are going to get, let's use say, this is the value now to 2 decimal places. As you are adjusting the value of your zero, the value of your thickness that you are getting will be changing until you get to the right thickness that you want. Then you say the equipment has been calibrated. For if you are calibrating for angle probe, definitely you have to need to have a curved surface. If this is your probe, you need to have a curved surface, whatever the shape is, but it should be curved, and this will give you your known distance. So in some books, instead of calling it calibration, they will call it range calibration. We will talk about this subsequently in this video. So this is what we do when we do calibration. Another way of also compensating for your delay is what we call the wage delay. Some equipment will call it wage delay, or some will simply call it delay. In some other units, it will have a delay and also have a zero. So to get your final calibration, you need to adjust your zero and also adjust your delay. If you look at this 38 Airport 650, if you look at basically it will have, if you come to the basic calibration, you are going to have both. As you can see, you have the zero and you also have the delay. This compensates for the delay variation and the velocity variation. That is for equipment calibration. Then when we look at the third term we often see, it is what we call the equipment check. A lot of times, UT inspectors, they don't do this. And especially when the client does not ask or when there are no issues, they don't do this. When you come to equipment check, you can come to your so you can check either of these two, your flaw detector check and your probe check. Why do you perform this check? Is to see, one, if the flaw detector is giving you accurate reading. When you perform a flaw detector check and it fails, it means you have to send the equipment back to the manufacturer or to an approved vendor that calibrates for the manufacturer. In this case, the calibration that is done on the machine is quite different from the calibration that you do when you want to test. So that is more of like a system calibration where they will use pulse generators and other things to set the equipment so that it comes back to its optimal condition. And basically, as per standard, you are expected to do your equipment calibration every year. So this kind of calibration settles for your equipment check so that by the time you perform your equipment check, you are getting the right result. We are also going to look at those checks subsequently in this video. Then the next check you also do before you perform your task, or that you are supposed to do. Some will require you to perform this task every 88 hours. The standard may require you to perform it maybe at the beginning of your shift or at the end of your shift. So we have the ones we do for the probe check. And I'll give you an example. Your index points that you normally check is actually an example of a probe check. You do that, whatever value you get, you impute into your units, and then you continue the work you do. So we'll subsequently look at each of these and how to do them, and then get a better idea on how to go about this. Thank you.